for Mr. Mutlu. Mr. Mutlu, over to you.
Thank you. Good afternoon to our grade 12 learners. Today we are going to focus on mathematics paper 1. This is for grade 10, 11, and 12. The topic is number pattern, sequence, and series. The mark allocation for our exam, media exam, for a grade 10 paper is a 10 out of 50, 10 plus or minus 3. For a grade 11 learner is 20 plus or minus 3 out of 150. For a grade 12 learner is 30 plus or minus 3 out of 150. Then you were introduced to a pattern in grade 10. In grade 10, we did linear pattern. What is a linear pattern? A linear pattern is a pattern that has a constant, first constant difference. First constant difference. Very important. In grade 11, you were introduced to quadratic pattern. Quadratic pattern, remember now, quadratic algebra, algebraic method. You must use algebraic method for this one. You in terms of defining a quadratic pattern has a constant, second constant difference. The difference between linear and a quadratic. A linear pattern has a first constant difference. The second one, which is quadratic, we have the second constant difference. We encounter sequences at the beginning of our mathematical experience. For example, listing even numbers like 2, 4, 6, 8, 10. That is a pattern. Listing odd numbers 1, 3, 5, 7. It's also a pattern. You can't predict what the 200th term of each sequence will be by just using the common sense. Another sequence of great historical interest is the Fibonacci sequence, in which each term is the sum of the two previous terms. Sequences arise in many areas of mathematics, including finance. For example, we can invest 1,000 at an interest rate of 5% per annum, compounded annually. The list of listing the sequence consisting of the value of the investment each year. That is the sequence. For first year is 1,000, second year 1,050 rand. Third year is 1,102 rand 50. That is the pattern. Sequence can either be finite or infinite. For example, we can have 2, 4, 6, 8, 10. The last term is 10. If we know the last term, then we have a finite sequence. Now let's go to an infinite sequence. An infinite sequence continues without bound. So it continues up to infinity. We use ellipses to denote that the sequence continues without a bound. For a given infinite sequence, we can ask the question, can we find a formula for general term of the sequence? Does the sequence have a limit? That is, do the numbers in the sequence get as close as we like to some number? Sequences and series are very important in mathematics and also have an application in physics, finance, and statistics. Now, in grade 12, welcome to grade 12. In grade 12, we introduced you to arithmetic sequence. Arithmetic sequence has a form. The first term is A in terms of arithmetic sequence. The second term is A plus D. The third term is A plus 2D, where each term is obtained from the previous one by adding a constant, also called common difference. So if we have a common difference, it means we have what? We have an arithmetic sequence. This is the same as a linear pattern that you did in grade 10. Now, the letter D, we usually use the letter D to denote what? To represent our constant difference or common difference. A is our first term. Now, the general term for arithmetic sequence. Where do we get the general term? The general term is in your formula sheet, the last page of your question paper. The general term of an arithmetic sequence. What is an arithmetic sequence? It has a first constant difference. Now, the general term for arithmetic sequence is Tn equal to A plus open bracket n minus 1 close bracket multiplied by d, where A is our first term. A is our first term, n is the term number, d is the constant or common difference, and then Tn is the value of the term. Please, guys, A is the first term, n is the term number. N is the term number, not the value of the term. The value of the term is represented by Tn. For example, now, let's get to calculation. The question, find the formula or the general term of the arithmetic sequence. Once you see the word arithmetic sequence, you must remember the formula for arithmetic sequence. What is the formula for arithmetic sequence? The formula for arithmetic sequence is Tn equal to A plus n minus 1 close bracket multiplied by d. You will then have to substitute and then use algebraic method to solve or simplify your answer. In this case now, the sequence is 2. The sequence is 2, 5, 8. The question is to find the formula for the nth term of the arithmetic sequence. What is the sequence? The sequence again is 2, 5, 8. Now, what is our first term? Our first term is 2, represented by an alphabet A. That is the first term. Then we have to find D. How do we find D? We find D, T2, which is term number 2, minus term number 1. Term number 3 minus term number 2. So the difference here is, our difference is going to be 3. Because 5 minus 2 is 3. 8 minus 5 is also 3. This is common. That is why we call it a common difference or a constant difference. So our D is now 3. Remember again that the sequence is 2, 5, 8. The first term is 8. The difference is 3. How do you find the difference? T2 minus the previous term, T3 minus the previous term. Then now you are going to substitute. You go back to your equation. The equation, remember, is Tn equal to A plus n minus 1 close bracket multiplied by D. Then you substitute. The value of A is what? Is 2 plus n minus 1. The value of D is what? The value of D is 3. And then you use our algebraic method. Remember question 1, paper 1. We did that, I think, this week on Monday. Solving this, the answer is going to be, now your simplified answer is 3n minus 1. Another question. Find the formula for the nth term of an arithmetic sequence. 107, the question now, the sequence is 107, that is the first term. The second term is 98. And then the third term is 89. Find the formula, or we can say, find the general term of this arithmetic sequence. The sequence is 107, 107, that is the first term. The second term is 98. The third term is 89. Remember now, we have now the word arithmetic sequence. You will get your formula where at the back of your question paper, the last page actually. So the last page, you get the formula. The formula again for an arithmetic sequence is Tn equal to E plus open bracket n minus 1 close bracket multiplied by D. What is our first term? A. A is the first term. The first term is 107. First term 107 plus substitution n minus 1. Now, what is the difference? How do we find the difference? The difference is T2 minus T1 or T3 minus T2. And the constant difference there is negative 9. So negative 9 is our D. Substitute negative 9. And then you will simplify this using algebra. Our simplified answer is 106 minus 9n. This is a linear equation function. Guys, that was arithmetic sequence. We also introduced to this year in grade 12 a geometric sequence. Remember, guys, for a geometric sequence, you must remember your exponential laws. We did that on Monday. Exponential laws. Question what? Repetition. In this case, the geometric sequence has a form of the first term of the geometric sequence is A. The second term is A multiplied by R. The third term is A multiplied by R squared, exponent 2. The third term is, the fourth term, A, the power of R, A multiplied by R to the power of 3. Guys, with this one, you should know that now, how do we find R? Or in this sequence, to obtain the next term, we multiply by a constant or a common ratio. Ratio, remember, you divide geography, you divide math, general math, you divide. So in this case, we divide term number 2 by term number 1, or we can say term number 2 by the previous term. We will then divide term number 3 by the previous term, which is term number 2. So in this case, the general term R can be positive or negative. The general term for this one is for a geometric sequence. The general term is Tn equal to AR to the power exponent. Exponent grade 10 word, grade 10 content, prior knowledge. R to the power of n minus 1. Now, still here, A represents the value of the first term. R represents the ratio. Now, for example, now we have a question here, another example now. Find the formula for the nth term of the geometric sequence. Find the formula for the nth term of the geometric sequence. Now the sequence, yes, the sequence. The sequence is 2, that is the first term. The second term is 6, and the third term is 8. You are told this is what is a geometric sequence. You must go to your formula sheet. You cut and paste your formula for geometric sequence. Now, in this case, now the formula again is Tn. Tn is the value of the term. Equal to A is the first term. Multiplied by R. R is our constant or common ratio to the power of n minus 1. In this case, the first value of the sequence, remember the sequence is 2, 6, 8. 18. 2 is 18. Now the first term is 2. Our A is 2. Substitution into a geometric formula. And then we then substitute the value of R. The value of R, remember, how do you find the value of R? T3 divided by the previous term, T2 divided by the previous term. Then the ratio in this case, our R is, guys, 6 divided by 2 is 3. 18 divided by 2 is 3. It's common. We call it a common ratio. So the common ratio is 3. To the power of, remember, your exponent, n minus 1. This is your what? That is your general formula of the nth term. Another question you will have to find again the formula for the nth term. Let's do this one. The first term is 486. That is our first term. The second term is 162. The third term is 54. Remember now, what is our first term? Our first term is 486, which is the value of A in our formula. And then how do we find the difference in here? The difference is this number divided by the previous number, which is term number 2 divided by term number 1, or term number 3 divided by term number 2. You find the difference, and then the difference in this case is 1 over 3. You can also have fractions, grade 11, grade 9. I think it's grade 9, yeah, grade 9 content. Fraction, the answer, the value of R is 1 over 3. Then you just substitute into our equation of geometric sequence. And then the answer is 486 multiplied by 1 over 3 to the power of 1 minus 1. You can simplify this further by using exponential law. We can also check whether a given number belongs to a given geometric sequence. For example, in that case, checking whether a given number belongs to a given geometric sequence. Now the question, does the number 48 belong to a geometric sequence, to the following geometric sequence? The sequence now is, in this case, our sequence is 3072. That is the first term. The first term, 3072. The second term is 1536. The second term is 1536. The fourth term is 768 to infinity. Is infinite sequence, infinite geometric sequence. Now, in this case, the question is, does the number 48 belong to this geometric sequence? Oh, now, the number 48, use the formula again. What is the formula for a geometric sequence? That is Gn equal to A multiplied by R to the power of n minus 1. So the term number now is 48, which is our Tn 48 substitution, and then the value of A is the first term. The first term is 3072. Now the ratio, our constant ratio or a common ratio. The common ratio in this case is 1 over 2. 1536 divided by 3072 is a half. That is our value of what? Of R. R is half, to the power of n minus 1. We will then use our algebraic method to solve this. If you can solve this, if you can find a number or a whole number for this solution, it means that number is one part of the geometric sequence. But if it's a rational number, or you can't solve the equation, it means it is not part of the sequence. So in this case, we can solve for this. And then in solving for this, we divide, remember, we are going to divide both sides by 3072. Divide both sides by 3072. And then your answer is going to be, now we are going to have 1 over 2 on your what? On your right hand side to the power of n minus 1. And on your left hand side, you are going to have 1 over 64. So 84 divided by 3072 is 1 over 64. Then now, use your laws of exponents. Using the laws of exponents, make sure that your bases are the same. Then you will what? Remember algebra, you equate the exponent. Now, in that case, after that, half I can write 1 over 6 as 1 over 2 to the power of 7. And then on the left-hand side, we have 1 over 2 to the power of n minus 1. So now our base is half on the left-hand side and on the right-hand side. So if the bases are the same, exponential laws, we equate what? We equate the exponent. All right. Now, another example here. In this case here, now, equating the exponent, sorry guys, that is 1 over 64 can be written as 1 over 2 to the power of 6, your error, to the power of 6. 1 over 2, let me use my calculator here, and then we have 1 over 2, all in all, to the power of 6. Let me see, to the power of 6. That is 1 over 64, correct. Then now our bases are the same, half up. We equate the exponent. Now the exponent on the left-hand side is n minus 1. On the right-hand side is 6. Then solve for x, solve for n. It's like solving for x in grade 10. You transpose that negative 1 in your left-hand side to your right-hand side. And then the value of n is 7. So this is the 7th term of the pattern. Another example, does the number 6072 belong to a geometric sequence? You apply the same method. So in this case, guys, your answer is going to be, you won't be able to solve for this using exponential law. In that case, if you can solve it, you know this does not form part of our sequence. So far we did linear, constant, first constant difference. Quadratic, second constant difference. Arithmetic, first constant difference. Geometric, a constant ratio. A constant ratio. 4 these types of sequence. Now, in grade 12, again, we introduce series. What is the difference between a sequence and a series? A sequence is like 1, 2, 3, 4, 5, listing a pattern. Pattern is a sequence. But now, what is a series? A series is the sum, addition of a sequence. Addition of sequence. For example, we can have the sequence multiples, even numbers 2, 4, 6, 8. If we add 2, 4, 6, 8, we add a sequence. It's called a series. We introduced a sigma notation during first term. Sigma notation is a symbol that is used for, like, usually in Greek. In Greek, it's sigma, but here in our South African, I think South African language, we call it S. S, which represents summing of a sequence. So sigma, I think I can't write that. I can't even. Okay, a sequence now. Okay, a sigma is something like E facing the other way around. E. On top of a sigma, we have a number, and below that sigma, we have a variable and a number. So the number, the value, or the number at the bottom of your sigma, that is the first value to be substituted into the general term. The general term is always on the right-hand side. And then the number on top of your sigma, that is the last value to be substituted into the general term. In this case, how do we find the number of terms? The number of terms, remember, is the number at the top of your sigma minus the number below plus 1 all the time. We say top minus bottom plus 1 all the time. Those are the number of terms. Now, summing the terms of an arithmetic sequence. Now, we are summing, it means we are forming a series. Now, what do we use? We have a formula for this one. And for examination purpose, you have to derive the formula. This one, you have to derive it. Then, what is the formula? Where do we get the formula? Again, the formula is in your formula sheet. So the formula for summing of arithmetic sequence is Sn equal to n divided by 2, open bracket, 2a plus another bracket, smaller bracket, n minus 1, close the bracket, multiply by d, and then another bracket, we close the bracket. That is the equation for arithmetic series. Please, guys, you have to derive this formula for your examination purpose. Now, summing the terms of a geometric sequence. Now, we are summing the terms of a geometric sequence. We are forming a geometric series. In this case, what is the formula for that? The formula is Fn equal to A, open bracket, R to the power of n, minus 1, we close the bracket, divided by R minus 1. Remember algebra now, R should not equal to 1. Because if R equal to 1, this is going to be undefined. Or again, the geometric sequence is for examination purpose. You have to derive the formula. Right, guys? Then now, let's go to problems involving simultaneous equations. Back to question 1. Remember this week, Monday, I said algebra is the mother of all topics. Algebra is the foundation of mathematics. All right. Now, simultaneous. Remember, simultaneous forms a part of question 1, which is algebra. Now, I said last week, this now are word problems. We will find word problems. When real life problems that need to be solved mathematically are given in words, the problem are called word problems. Then how are we going to solve this word problem? The first step, remember, you have to understand the problem, understand the scenario, take your time, read. The second step, make a plan. How do we make a plan? A mathematical plan. you write the problem down in mathematical terms. The third step, you have to work your plan. Now you solve the problem. You solve the problem using what? Using algebraic method. Question 1, application. The last step, you assess the answer to the problem. You check if your answer holds. You check whether your answer is valid or not. Now, let me, I think I have an example somewhere here. Yes, I have an example here. Using simultaneous equations in arithmetic sequence, integration of two topics. Please, guys, you will get such questions where we integrate sequence and series with what? With algebra, or we integrate that with functions. More especially functions where in a quadratic pattern. Quadratic pattern is a parabolic function. We can find the maximum or the minimum value of the function. So it means we can find the minimum term or the maximum term. All right. Now, the question, example, using word problems. Now, the question is, determine, here's the question, guys, determine the first three terms. Determine the first three terms of an arithmetic. Where's your formula? Your general term. Determine the first three terms of an arithmetic sequence if the fifth, term number 5, of the sequence is 12 and the 14th term is 33. Okay, Menier, now I understand the statement. Step number 1. Step number 2, we take this, what is the step number 2? We make a plan. We write the problem down in mathematical terms. Now, term number 5. How can we write term number 5? The first thing, what is your general term? Your general term is Tn for an arithmetic sequence equal to A, open bracket, n minus 1, we close bracket, multiplied by D. Remember, plus between the first the bracket and A. In that case, then, what are we going to do? Substitution. You are told that the fifth is the term number, the value of n. All right. Then we are given once again that term, the value of that term is 12. So term number 5 is 12. So you substitute and you leave the variable a and d. After that, just simplify your equation. After simplifying my equation, on my left-hand side, I have a plus 4d equal to 12. That is my equation number 1. Remember simultaneous equations, solving for simultaneous equations in question 1. This was the same question, repetition in mathematics. You did simultaneous equation when? In grade 10. All right. Now, another term, we were told that the 14th term is negative 33. In this case, now again, this is the 14th term of what? Of an arithmetic sequence. Where is the general term of an arithmetic sequence? Yes, here's the general term of an arithmetic sequence. That is Tn equal to A plus or open bracket n minus 1 close the bracket multiplied by D. Simple guys. Then now you substitute. Do we have the value of A, the first term? No. Now, do we have number Tn? Yes, Meniere, the value of the term is given. That is negative 33. Are we given the value of D? No, sir. But the term number is 40. Substitute, use your algebraic method. Then we have the equation is now A plus 13D equal to negative 33. Now we have two equations of the same arithmetic sequence. Remember now we can solve for both A and D, the first term, and the difference. How are you going to solve that? You solve that simultaneously. You can use elimination method or substitution method. And then using that, the value of B is -5. Then the value of A is going to be 32. After this, now we have the first term. Remember the question. Let's go back to the question. The question determines the first 3 terms of an arithmetic sequence. If the fifth term of the sequence, the fifth term of the sequence is 12, and the 14th term is -33. Now we have to find the first 3 terms. Now you have the first term and you have the difference. You just add D, you add D to get the next term. So remember our value of D here is -5. The value of A is 32. 32 plus 5, we get the second term, that is 27. 27 plus, -5. 27 plus -5, that is 22. So our first 3 terms of the sequence is 32, 26, 27, 22. First 3 terms, 32, 27, 22. All right, guys. Now, let's go to the next question. The next question is hence determine the 40th term. Oh, yes. I know now the value of A, I know D, and N is given, N is 40. Substitution, and then you solve for your answer. Your answer, term number 40, is -163. -163. Solving simultaneous equation. In grade 12 again, we did sum of infinite geometric sequence. Remember, guys, we can only find the sum of infinite geometric sequence if that sequence converges. If the sequence converges, the sum to infinity exists. But if the sequence is divergent, remember we use these terms in geography: diverge, converge. So the convergence sequence, the divergence sequence away from the equator in geography. Now, in that case, if your sequence diverges, guys, in mathematics, we integrate functions here. Exponential function. Exponential function, for an increasing function, it goes to infinity. It approaches infinity. For a convergent, remember at the equator in geography, you converge at the equator. Now we are approaching the x-axis in mathematics. Approaching the x-axis, if the equation is maybe the standard form of exponential equation, we have y equal to maybe 2 to the power of x. We know then we are approaching what our asymptote is a 0. So for that term, y is equal to 2 to the power of x, the sum to infinity, maybe, but the other way around, it should converge, remember. It goes to 0, approaches 0, as the value of x increases. Now, guys, the formula for this one, for sum of infinite geometric sequence, the formula, this one is not for, the derivative of this, deriving this formula is not for your explanation purpose. Sum to infinity of a convergent geometric sequence, only for a convergent geometric sequence. You can't find the sum for a divergent geometric sequence. Sum to infinity equal to a over 1 minus r, where r is between -1 and 1. Guys, this formula is important, very important for recurring decimals. Like, for example, convert a recurring decimal 2,53535 to infinity into a common fraction. We can use algebraic method, the 10 method. where we let maybe x equal to 0.5353. But in this case, we can also use sum to infinity, integration of two topics. Now, how are you going to use the sum to infinity in this case? Your recurring digital can be written as what? As a pattern. For example, we can have recurring now 0.53 plus 0.0053 plus 0.000053 to infinity. So with this one, that is your what? That is the geometric what? Our geometric series. You can find a geometric series if only the function, not the function, sorry, the sequence converges. How do we know the sequence converges? The value of r should be between -1 and 1. And what is our value of r in this case? The value of r is 0.01. Then finding the sum to infinity of the recurring, that is 53 out of 99, plus 2, remember the number before your decimal, and then your answer is in next fraction, which is 2, and then that is 53 over 99. And then let me just wrap up this. What you need to be able to do or know for examination purposes. You have to find the next few terms of a given sequence. You have to identify arithmetic sequence, quadratic sequence, and geometric sequence. You have to apply knowledge of sequence and series to solve real-life problems. Find the first difference and the second common difference in a quadratic sequence. Find the general term of the sequence. Know how to derive the formula for sum of an arithmetic and for a geometric sequence. Series. You must also solve problems using some formulas. Work with the sum of infinite geometric sequences that converge. Remember, in terms of our mark allocation for this coming exam, June exam, grade 10 learner, 10 marks plus or minus 3 out of 150. For grade 11 learner, 20 marks plus or minus 3 out of 150. So for grade 10, it's out of 50. For grade 11, it's 150 total. 20 out of 150. For grade 12, it's 80 plus or minus 3 out of 150. Remember to master algebra and function for you to get good marks in this topic of sequence and series. Abdineo, Abdineo, are you available? Okay. Abdineo? Ke bona sexeletse ke 5 minutes. Ke bona ke saletse ke 5 minutes.
Oh potso e keneng ka monana e batla potso enana moithuti o nana o sendile snepe ka monana wena ntate Motloung ne so ke ne ke shebile hore ko romelle sona snepe senana ka bane o batla ho tseba question enana e hlaile monana so o shutile snepe so jale ka baka la go se go tshwere ka marangrang a gokahanyo ke nana hore ke tla o sendela sona snepe seo o se etse ha ka ta o se etsa wena o nsendele tsona ta mona nna ke sendele moithuti o tla mono o mong fela molaetsa fela ke molaetsa o leboang fela hore ba leboa hore o thusitse ka nnete a re fela moithuti o na sa utlwisisi di sequence series tsena empa ka lesena ka jeko fela o sa thotse bohlalenyana and o sa bone lesedinyana.
No ke le wile haholo ke le bola ba ithutwana ba rona mo malapeng ke kopa ba itshware hantle se di fadile hane.
Eya ntate Motloung.
Alright, no ke le wile haholo ntate.
Ke se re tla kopana hape ka the next lesson ya mathematics ntate Motloung.
Re tla kopana ka functions.
Functions. Okay ntate Motloung.
Thank you very much for it.
O leboa nna.
Thank you.